Okay, so this is me reviewing the yellow, and I'm on set 1 of the target practice. So I am going to, again, I'm going to take my book. I'm going to start by writing my name. I'm going to write what color it is on the target that I picked up. So yellow. And I'm going to write what set it is. It is at the corner of the paper. You're only looking at the side with the letters, not the back, just the front. So set 1. So section A, I'm going to do up here. And I'm going to, for section A, I'm going to use benchmark fractions. So benchmark fractions. Oh, ran out of room. Benchmark fractions. So I'm looking at the information for A. Need 2/3 cup of sugar for pancakes and 3/4 cup of sugar for syrup. Okay. So A tells me that I need to make a little number line. Here is 0. Here is a half. And here is 1. 1 whole. Okay. 2/3 is 2 more, less, or equal to half of 3. Well, half of $3 would be $1.50, or half of 3 Skittles would be 1.5. So 2 is more than that. So I know that this number right here is somewhere along there. Okay. I'm going to look at the other number. I'm going to do the same thing. 0, a half, and 1. Should have moved my line down some. Okay, so 1 right here. So the next number that they gave me was 3/4. 3/4. So this number is somewhere over here. Okay, 3/4. What's half of 4? Half of 4 would be 2, right? So I know that 3 is more than half. Okay, and really, if I cut this number line into fourths, right, this would be 1/4, 2/4, 3/4. So it would actually be, let me change colors real quick. It would be that 3/4 would be right here, covering that area. Okay, so I use those benchmark fractions to figure out where they would be on a number line. So that's section A. So section B, using the same information because the B is up here, just this information. Section B, I am going to model adding fractions with unlike denominators. So I'm going to model adding fractions. Okay, what you need to know, these are my numbers, 2/3 and 3/4. 2/3 and 3/4. Okay. Here I'm going to make me a little box, and I'm going to use that 3 sections right there. So 1, 2, 3. And I know that 2 of them are shaded. So 2/3. I'm going to do the same thing here. They've got to be the same size. Okay. So I have the 3 there, but this time I'm going to break that. I'm going to break that into 4 sections because my denominator is a 4. Whatever your denominator is tells you how many pieces you have total. And then the numerator, so numerator, denominator. Denominator tells you how many total pieces. Numerator tells you how many are shaded. Okay. So here I know that 3 of the 4 are shaded. The second piece to this is to put these together, okay? So I'm adding those. So if I took those same box, now if I took that same box and put what I did together into one box, I have it split like this for the thirds, okay? 2 of them were colored in. I had it split into fourths, and 3 of the 4 were colored in. Okay, I shouldn't have done that right there. So back up, ignore that for just a second. So I'm gonna take that away in just a second. But really I should have done this right here, the 3 boxes, the way that I just said, where I have the 3. So 2 of them were colored, and then I'm just going to cut it into the fourths because I'm adding it on. And what I see is really 2/3 is the same as, how many are colored in now? 1, 2, 3, 4, 5, 6, 7, 8 out of 8, 9, 10, 11, 12. Okay, so this becomes 8/12. And then here I'm going to take that same box that I had earlier. I had it cut in fourths. I had 3 of them shaded in. Okay, and now I'm going to cut it into thirds that I have the other box. And that becomes 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 3/4 is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 9, 10, 11, 12. So what happens is I get a common denominator, okay? So I'm going to ignore this that I did a while ago. I got a common denominator. And now whenever I want to add these, all I have to do is take the 2 numbers that I got with the same denominator and add them. So I'm going to do 8/12 plus 9/12. So 8 plus 9 is 17/12. Okay? 17/12. This is an improper fraction, remember? If the top is bigger than the bottom, it's improper. So how many 12s can I take out of 17? I can take 1, and it would leave me with 12. It would leave me with 12. Take away out of 17 is going to leave me 5/12. So it's either 17/12 or your answer is 1 5/12. Okay? So ignore that piece and fix that for me. So that's section B. Section C, you're using the exact same information right here, the 2/3 and the 3/4, and we are simply going to add fractions with unlike denominators. Add fractions. So we modeled them a while ago, and now we're just going to add them. So 2/3 plus 3/4, we have to have a common denominator on the bottom. Another way that I could get a common denominator is simply by multiplying those 2 numbers. What's 3 times 4 is 12. So 12 is a common denominator. What did I do to 3 to turn it into a 12? I multiplied it by 4. So what I do to the bottom, I must do to the top. So 3 times 4 gave me 12. Okay, this goes right here. And then what I do to the bottom, I have to do to the top. 2 times 4 is 8. I'm going to do the same thing over here. What did I do to 4 to make it turn into a 12? I times it by 3. So what I do to the bottom, I must do to the top. Times 3, so it gives me 9. And then again, I leave my denominators the same, and I add. So 8 plus 9 gives me 17, and I keep the denominator. Okay? So that gives me the fraction equals 17/12. Or I can convert this, so this is improper fraction. I can convert it back to a mixed number. How many 12s can I get out of 17? I can get one whole. So 17 divided by 12. The top number would go in the box. 12 goes into 17 one time. It doesn't go into 1. It goes into 17 1. Gives me 12. Leaves me with 5. That way, this becomes my numerator. This becomes my denominator. This is my whole number. So in 5 12ths. So it's just a trick for you. I'm going to show you another way that you could have lined up your question for C. You could have lined it up where it's 2/3. So on your paper, you could have done 2/3 plus 3/4, converted this. You knew that the bottoms were 12 because 3 times 4 is 12. So that gives you a common denominator. Then you'd say what you do to the bottom, you do to the top. That gives me 8. What you do to the bottom, you do to the top. So 4 times 3 is 12. So that's how I knew to multiply this by 3. That's 9. Then add your two numbers, and that would give you 17 twelfths, okay? Which equals 1 5/12. So you could have lined it up like that as well, whichever you like better. Okay, so after C, I am going to, so D is going to be represent multi-step. So D, multi-step. So again, I'm still on my yellow section. Pause that. And then I'm going to flip over to D, and it gives me my question. Let me see if I can get that whole thing in. Okay, so D, I'm still in the yellow section. Jay fills his car with gas once a week. He pays $4 per gallon. He used 1,404 gallons last year. How many gallons does his car hold? Well, he fills up his car once a week. He pays $4 per gallon. He used 1,404 gallons last year. How many gallons does his car hold? So do I really care about the money at this point? No. So what I'm going to do is it's a word problem. So if you're working with a word problem, I do want you to set up RIPs. So on the word problems for yellow, the D, I do want you to do RIPs on them. Okay, so the question was, how many gallons does his car hold? How many gallons does his car hold? Okay, I know that in the year, it says in the year he used 1,404 gallons last year. So 1 year equals 1,404 gallons that he used. Okay. And he fills his car up once a week. So I need to know something about weeks and the year. So fills car once per week. It tells me that there's $4 per gallon. Am I doing anything with money? Is the question asking about money? No. So that is not important information. To problem solve this, I'm actually going to, another important information is that there are 52 weeks equals 1 year. Okay, that is not on my question. That's something I need to know or find it on my math chart. To problem solve this, I'm going to divide. So my process is to divide. I'm going to actually divide all the gas that he used in the year by the 52 weeks to find out how much gas he used per week, and that'll tell me how much his car holds. So 52 does not go into 1, and again, to divide, I'm using DM, SB, divide, multiply, subtract, bring down. 52 doesn't go into 1, doesn't go into 14, but it goes into 140. It'll go in 2 times. So 2 times 2 is 4. 2 times 5 is 10. Or 2 times 52 would give me 104. I'm going to subtract. I can't take 4 from 0. I borrow, that becomes 3. This becomes 10. 10 take away 4 is 6. 3 take away 0 is 3. 1 take away 1 is 0. Then I'm going to bring down the 4. 52 goes into 364. Well, I don't really know. Okay, so I've got to do some math there and figure that out. So 52 will go into 364 how many times? Well, I know that I can go by 50s and go 50, 100, 150, 200, 250, 300, 350, and get 7. So let's try 7. So 7 times 2 is 14. Carry the 1. 7 times 5 would give me 35 plus the 1 would give me 36. When I subtract, I'm left with nothing. I am at the wall. So his car holds 27 gallons of gas. That would be my answer. So I solved that using RIPS. I'm now going to go to section E. And section E is division. So I flip to the chart to section E. It gives me division and then division with decimals. So I'm going to work them both. Okay. So I'm going to set up one problem over here. 2,305. I'm getting my numbers from section E right here. Divided by 5. Again, for division, remind yourself it's DMSB. So 5 doesn't go into 2. 5 goes into 23 4 times. 4 times 5 is 20. I subtract, I'm left with 3. Bring down the 0. 5 goes into 30. 6. 6 times 5 is 30. I subtract, I'm left with 0. Bring down the 5. 5 goes into 5. 1 times 5 is 5. I'm done. I have 0 at the bottom and I'm to the wall. So therefore, my answer there is 461. Now I'm going to divide this one with the decimal. Okay, this is going to be a little bit different. So 23.05 divided by 5. Okay, doesn't have a comma in there, it has a decimal. I'm going to divide the same way though. 5 doesn't go into 2. 5 goes into 23 4 times. 4 times 5 is 20. Subtract, I'm left with 3. Bring down the 0. 5 goes into 36. 6 times 5 is 30. Subtract, I'm left with 0. Bring down the 5. 5 goes into 5 one time. 1 times 5 is 5, leaves me nothing. Okay. My decimal goes straight up when I divide. Okay. So wherever it is in the problem, it goes in the answer. Or I can count back 1, 2, 1, 2. Okay. So 4 and 61 hundredths, or 4.61, which is very different than the whole numbers, right? I have a decimal in this answer. Good. Section F in the yellow target practice is going to be about conversion. So you are converting, conversions. And if I flip to section F, I see that it says 5 yards equals how many feet? So I'm going to write that problem. 5 yards equals blank feet. Well, on my math chart, I know that 3 feet equals 1 yard. Okay? So I would actually, to find out what 5 yards equals, I would need to multiply. For every yard, I need 3 more feet. So I would actually multiply. So here is 1 yard equals 3 feet. I would multiply these two to get this answer. Okay. So that was just my measurement off the conversion chart. So 5 yards times 3 feet, yards, times feet. 3 times 5 is 15, so it will give me 15 feet. Okay, and I get this information off of my math chart. Okay, so just in case you need this, this was for the conversion piece, but again, this is on your math chart, okay? So that will conclude the yellow target practice video, and then we will move on to the other colors.